Alright, so there shouldn't be anything like mind-blowingly new in this section. This is going to be a review of stuff that hopefully we've seen before. It may have been, a long time ago or just last semester, but we're going to do a review of parametric equations. So recall that a parametric equation is whenever we take this variable t, or we could use other variables if we want, but generally we use t. And what we do is we write our x value and our y value in terms of t. And then we can look, when t is equal to 0, where's our point going to be? When t is equal to 1, where's our point going to be? And it's going to give us a graph. The big thing that we need to remember, a difference between, a Cartesian function, right, where we just have something like y equals x squared, and a parametric function, is that our parametric function is going to have a direction associated with it. So we need to use arrows to indicate this direction. So let's look at what this means. Let's look at example 1. Well, looking at example 1, kind of like our primary way of graphing these, at least when we were starting out, was to kind of just make a table of t, x, and y values. And the way we did this, so I generally do like -2, -1, 0, 1, and 2. Normally gives me a decent idea. So I'll plug in -2 into our x function and into our y function. So for our x function, I'd be using this t squared plus 3t. So this would give me -2 squared, which is 4, minus 6. So this would give me -2. And then for y, I would have -2 times 2, right? This part right here, plus 5. So that would give me a positive 1. Now, for t equals -1, I would have, for the x value, -1 squared is 1, minus 3 would give me -2. Then for, we'd have, plugging in -1 into our y function, we'd have -2 plus 5, which gives us 3. Then I'm going to go ahead and do 0, 1, and 2 as well, just so we can get a rough idea of what this is going to look like. Okay, now that we have this, I'm going to take a look at what do we think this graph looks like. Okay, so let's see, I'd have the point, I'm going to start with t equals -2, and so I'm going to use the point -2, 1. So let's see, 1, 2, and then up 1, so that'd give me a point right here. Right, that's when t equals 0. Then when t equals -1, we would be at -2, 3. So maybe somewhere in here. And then at t equals 0, we'd be at 0, 5. Okay, so up here. Right, and then it looks like my other points are going to kind of go off in here. So kind of when I graph this, what I'm getting is some picture that looks like this. Right. We're going to see in a little bit here, this isn't exactly right. Okay. One way to tell whether this is right or not is to put this in terms of a Cartesian equation. We understand Cartesian equations pretty well. Like if you see an x squared, you know that's a parabola. We have a general idea of what ln, e to the x, certain things we know what they look like. So that's what I'm going to try to do. So I'm going to focus on, let's see, we have x equals t squared plus 3t. And y is equal to 2t plus 5. And so in something like this, I'm going to try to get t alone. So on the right-hand side, I'll have y minus 5 divided by 2 will give us t. So now I can plug that into my x equation. So I'll get x equals, so I'm using t right here for this t value right here. So we're going to have y minus 5 over 2 squared plus 3. And so now we know more of what this looks like, right? This is an x equals y squared type of graph. So this green function that I drew should have actually looked more like this, right? It should be a horizontal parabola. Right, and so when we're asked to sketch a curve, this is kind of what I'm talking about. Get a few points that you know are correct, and then we can go to our Cartesian equation, and that'll give me an idea of exactly what it looks like. Now, one mistake I've made here is that I've drawn this orange graph as a Cartesian equation. What I need to do is draw it as a parametric equation. What that means is I just take this parabola and indicate what direction it's going. Well, we know that we were here at t equals 0, and then we went to here at t equals 1. So I'll draw my arrow going this way, and then we keep moving this way, and so on. Right? And so these arrows indicate what direction we are traveling on this graph. Okay. Now let's look at the other part of this question, which was to determine if the point 10, 8 is on the curve. Well, notice that 10, 8 really isn't kind of in the picture of this graph that I've drawn. So instead of just looking at a picture, what I can do here is I can say, well, let's suppose this point is on the curve. That means that x is equal to 10 and y is equal to 8. Well, our function for y is 2t plus 5. So that means that 2t plus 5 must be equal to 8, which gives me that t is equal to 3 halves. So if I plug in t equals 3 halves into my x equation, I should get 10. Well, that'd give me x equals 3 halves squared, so that'd be 9 over 4, plus 3 times 3 halves, so that'd give me 9 over 2. That would be equal to 27 over 4, which is not equal to 10. And so that tells me that 10, 8 is not on the curve. Okay. So now let's suppose we have these x and y functions of t, and we're asked to sketch the graph of the curve and find the corresponding Cartesian equation. Well, the first thing I'm going to do is find that equation, because that'll help me sketch this curve. So I notice here that x is equal to cosine of t, and y is just the same thing, but we square it. So we can really say that y is equal to x squared. Because if I take the x function, which is cosine, and then square it, I get exactly what I have right here. Well, we know what this graph looks like. This graph is a parabola. But something we need to consider here is the domain of this. Notice that x is equal to cosine of t. That means x has to be between 1 and negative 1. Right? Because that's the range of our cosine function. Now, y is equal to cosine squared. So that means that y has to be in between 0 and 1. So when I sketch my graph, I'm going to pay close attention to that. So a parabola would look something like this. Now, let me graph this a little bit better. Right? So we'd have 1, 1, 2, 4. Right, so a parabola would traditionally look something like this. However, we need to keep in mind these parameters on x and y. Our parameters for x and y tell us that we're going to kind of be restricted to this box right here. Right, because x should be between negative 1 and 1, and y should be between 0 and 1. Okay, so what I'm going to do is just draw my curve inside this box. Okay. Now the only thing we have left to do is to find the direction. To do that, I'll start off with, say, t equals 0. Well, when t equals 0, x will be equal to 1, and y will be equal to 1. So that's going to be this point right here. Now, when t is equal to, say, pi over 2, we would have x is equal to 0 and y is equal to 0. So then we travel to here. Okay. Now, when t is equal to, say, pi, we'll get x equals -1, and y is equal to +1. So we'd be right here. Now, something special that happens in this graph is, okay, well, what if we increase our t value? Right? What if I do t equals 3 pi over 2? Then we'd go back to x equals 0, y equals 0. So we travel in this direction first, and then we kind of bounce back. Right? So then we would head back in this direction. And then once we reach this point, we would bounce back in the other direction. So it'll kind of just be traveling along this curve back and forth. So that's why we have these two contradicting sets of arrows. Okay. Now let's look at example 3. So for example 3, whenever you have x equals something with a sine of t in it, and y equals something with a cosine of t in it, we should immediately be trying to get the sine and cosine alone. And then what we'll do is we'll square them and add them together. The reason for that is because if we get them alone and square them, then we'll have, something on the left-hand side with x equals sine squared. For the other one, we'll have something on the left-hand side with y equals cosine squared. When I add these together on the right-hand side, we'll get sine squared plus cosine squared, which will give us 1 by our trig identity. So that's why I'm trying to get sine and cosine alone here. So let's see how this works out. Well, for the x equation, we'll get x over 4 equals sine of t. For the y equation, we'll get y over 4 equals cosine of t. Now what I'm going to do is square these. So we'll get x over 4 squared, sine squared of t, y over 4 squared, cosine squared of t. And now I'm going to add the left and right hand sides together. So I'll get x squared over 16 plus y squared over 16 equals sine squared plus cosine squared, which is equal to 1. Now I'm going to multiply both sides by 16, and we'll be able to see that this is the equation for a circle with radius 4. So now I'll go ahead and draw that. So I have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Alright. That actually may be one of the best circles I've ever drawn in my life. Alright, so silent applause for that I hear in the background. And so now the only important thing left is to determine the direction on this curve. So if I start with t equals 0, I would have gotten x equals 0, y equals 4. Right, that's just by plugging in 0 for t in these equations. If I did t equals pi over 2, I would get x equals 4, y equals 0. So let's see, I just went from 0, 4, which is right here, to 4, 0, which is right here. So I know that the direction I'm traveling in is going to be this direction. And we'll just keep on going around this circle over and over again, like Nelly would say. Okay. Now let's look at example 4. So again, I see x equals sine of t, which is great. And now I'm expecting a y equals cosine of t, but I don't get it. Right? Instead, someone was rude and gave us x equals sine of t, y equals cosecant of t. But cosecant of t is the same thing as 1 over sine of t. And so now I can use this substitution to say that this is just 1 over x, because sine of t is equal to x. And then what I need to be careful of is the domain for the t values. Right? So we know that this function should look something like this, right? That's the 1 over x graph. And then now I'm just curious about, okay, well, what part of this function lies in these t values? So I'll start at t equals pi over 6. There I would get x is equal to 1/2, y is equal to 2. Then I'll move to t equals pi over 2. I'm not going to do the values in between, and you'll see why. So this is going to be x equals 1, y equals 1. So x equals 1/2, y equals 2. Let's see if this is 1, 1, 2. Then that would be right about here. And then t equals pi over 2, that would be here. And so really we're just kind of concerned with this part of the curve right here. And we've already gotten the direction, which is that it moves like this. Alright, now let's finish this off with example 5. For example 5, we have x equals 2 plus cosine t, y equals 1 plus sine t. So I can get cosine and sine alone. That will give me x minus 2 equals cosine t. Y minus 1 equals sine t. We'll square these. And then add the left and right sides together. So we'll get x minus 2 squared plus y minus 1 squared is equal to 1. So this will give us a circle with radius 1. But it's going to be centered at the point 2, 1. Right, the reason for this is we'll have to remember if we have x minus h squared plus y minus k squared equals r squared. R is the radius of the circle and h, k is the center of the circle. So I need to go to 2, 1. That'll be my center. So I'll have a point here, a point here, here, and here. All right, and now I just need some direction. All right, and so as the professor, that's what I'm here for, guidance or direction. That's why I'm good with parametric equations. So let's see, t equals 0, we would have x equals 3, y equals 1, t equals pi over 2, we would have x equals 2, y equals 2. So I'm traveling from 3, 1, which is located here, to the point 2, 2. That would be located here. And so that tells me that my direction is going to look like this. Alrighty. Thank you for watching this video. Hope it wasn't too bad. This should just be a brush up on parametric equations. If you're really lost here and you just don't remember anything, please let me know. I have tons of resources on this. I can give you, things from last semester that we used to teach this, and just various different things to review.